Welcome to qnawire.
We're given an acceleration, which is a root t, and a in this problem is just 2, so we'll rewrite that. And we also know some initial conditions where when t equals 0, our velocity is 7.5 and our position is 0. And so in order to get our velocity, we know that from the definition of acceleration, it's dv dt. So we can say that the integral of dv is going to be the integral of a dt. And the left side, we get velocity. Now we have to integrate our acceleration, which is 2.0, and I'm going to write square root of t as t to the 1/2, just to make it easier to use our power rule, and dt. So now we just integrate. So this is going to be 2.0 is just a constant. T to the 1/2, you increase the 1/2 to 3/2 and then divide by 3/2, so we'll multiply by 2/3. And we need a plus c here. So our velocity as a function of time is 4/3 t to the 3/2 plus c. And this is all possible velocities. But since we know that the initial velocity at t equals 0, once we plug in 0 for time, this is going to equal 7.5 meters per second. And this just is 0. So our c is 7.5. So our one velocity function that fits all these criteria is 7.5 plus 4/3 t to the 3/2. Now, if we want position, it's the same thing we just did. We know that velocity is dx dt. And so we can integrate dx and integrate, let's see, v dt. So our position as a function of time is the integral of what we got up here, 7.5 plus 4/3 t to the 3/2 dt. Now we just integrate, so 7.5, we add a t, and 4/3 times t to the 3/2, so we integrate and add 1 to 3/2, and we get t to the 5/2, and then we have to divide by 5/2, so multiply by 2/5. And instead of c, because we use c in the last part, I'm just going to use d. It's a different constant, but it doesn't matter. And so we know our position function is going to look like this. This is going to be 8/15 t to the 5/2 plus d. And up here, we know that our position at time t equals 0 is 0. So we'll solve for d using that. 7.5 times 0. And this is all going to equal 0. Now this term goes to 0, this term goes to 0, so that must mean that d equals 0. So our position as a function of time is 7.5t plus 8/15 t to the 5/2. Now we want to know all three of these, our position, velocity, and acceleration at time t equals 5. So I'll just go through all these functions. Our a is going to be 2 times square root of 5. and that gives us about 4.5 meters per second squared. And our velocity at 5 is 7.5 plus 4/3 times 5 to the 3/2. And that gives us about 22.4 meters per second. And finally, for our position, 7.5 times 5 plus 8/15 times 5 to the 5/2. And so our position at time t equals 5 is around 67.3 meters.